question is, a right angle triangle has height h centimeter and base b centimeter. The hypotenuse of the triangle has length square root of 13 centimeter. If the area of the triangle is 3 centimeters square, find the possible values for b and h. Considering this as a right angle triangle, 90 degrees at this point. Height is h, so let's say this is the height h, and base is b. The hypotenuse of the triangle is the square root of. So clearly it is visible. We can use Pythagoras theorem and we will end up getting a equation. We know area is equal to half
Base times height divided by 2.
times base times height. Okay, so area is 3 centimeters square. That means we can put half times base times height is equal to 3 centimeters square. Let's multiply 2 both the sides. We will end up getting base times height is equal to 6 centimeters squared. This is one part of the equation that we will need, and the other one is when we use Pythagoras theorem in this one. Pythagoras theorem is like hypotenuse square is equal to opposite square plus adjacent square, or perpendicular square plus base square. You can also write it like this, like c squared is equal to a squared plus b squared. It depends on you. So this is the Pythagoras theorem. C is supposed to be the hypotenuse. So square root of 13, of course, squared, because this is the hypotenuse, is equal to h is, let's say, a, so h squared, plus b remains the base, so b squared. So this will give us square root of 13 squared is 13. 13 is equal to h squared plus b squared. You can also write it as h squared plus b squared is equal to 13. This is the second equation that we will need. Now what I will do from the first equation here, which is b times h is equal to 6, I'll try to figure out the value of either h or b and will substitute in this one. So from this equation, if I try to find out the value of b, for instance, so b is going to be equal to 6. We'll divide h both the sides, so b is equal to 6 over h, right? Now this value is getting substituted into here. So what we will get is h squared plus b is 6 over h, and it was squared, that's why I will make it whole squared, is equal to 13. Let's try to simplify this. So h squared plus 36 over h squared equal to 13. I know here h squared is having denominator 1. If there is nothing as a denominator, then it is considered 1, right? Now to
Yes, sir.
add them, we have to make the denominators same, because h squared plus 36 have different denominators. I'll multiply h squared in the numerator as well as in the denominator. So I will get h with exponent 4 over h squared plus 36 over h squared is equal to 13. Now I see we have common denominator h squared. So what I will do is I'll take it as common denominator h squared, and in the numerator part of this fraction, h with exponent 4 plus 36 will be written as it is, equal to 13. I want to remove the denominator, which is h squared. So what I will do, I'll multiply both the sides by h squared here as well as here. Now I see here we have h squared in the numerator as well as in the denominator, will get cancelled out. Now I have h with exponent 4 plus 36 equal to 13 h squared. I don't want 13 h squared to the right hand side. I have to bring it to the left. So what we can do is, let's subtract 13 h squared both the sides. So h with exponent 4 plus 36 negative 13 h squared on the left hand side as well as on the right hand side, where we already have 13 h squared. So we are subtracting 13 h squared both the sides. So here 13 h squared minus 13 h squared becomes 0. Finally we will get another equation. It is considered as a biquadratic equation. Why biquadratic? Because highest exponent of this equation is 4. What I end up getting is h with exponent 4 negative 13 h squared plus 36, I guess. Yeah. And on the right hand side I have 0. This is a biquadratic equation. I have to convert it into quadratic because I'm going to use quadratic method. Though there are many ways I can also solve it. with the help of factorization. But I'm going to use the quadratic formula to solve this. This biquadratic has to be converted into quadratic. What I'll do for that? Let's say I am going to take h square is equal to any other variable. Again, v. Then what will be h with exponent 4? Squaring both the sides. What you will get if you do squaring both the sides? Let's say h squared is
H
equal to
to the power 4 and v squared.
exactly. So now you have h with exponent 4 is equal to v square. So now we have v squared negative 13. What is h squared? V. So I will remove substitute v at the place of h square, which means I have v here, and then plus 36 equal to 0. Now this is the quadratic equation I was looking for. When I will compare with the standard quadratic format, which is ax squared plus of bx plus of c equal to 0, what I will get is a is equal to 1 because coefficient of v square is nothing but 1. B is the coefficient of x. At the place of x, we have v. So here we have negative 13. So b is going to be negative 13. And c is the constant, which is, of course, the 36. So where I'm going to use all these values a, b, c. Quadratic formula. Negative of b plus minus square root of b squared negative 4ac over 2a. What is the value of b? Negative 13. I have to substitute the values of a, b, and c. Negative, so negative of negative 13 plus minus square root of negative 13 squared, and then negative 4 times what is a? Of course, 1. What is
1.
c?
36.
36. And whole divided by 2 times a, 2 times 1, which is going to be 2 only. V equal to 13. Negative, negative 13, negative outside the bracket inside is going to be
Yes.
positive, of course.
That means that was
Plus
not the
minus the square
problem.
root of 13 square is 169. Negative, because negative 4 times 36, 144. Whole divided by 2. My dear, this is not the end of question, I guess. Still, you have to find the h and b. 13 plus minus the square root of 25, which will end up being 5 over 2. So now we have v is equal to 13 plus minus 5, because the square root of 25 is 5 over 2. So here you will have two values of v, which is going to be 13 negative 5 over 2 and 13 positive 5 over 2. As we all know, quadratic gives us two values. So now we have v is equal to 13 negative 5 is 8 over 2 is 4, and 13 plus 5 is 18 over 2 is 9. So I now get back to this part. H square is equal to v. V is equal to h square, or h square is equal to v. Both the values. H square is equal to 4. So h is equal to, applying square root both the sides. Left hand side will become h, and the right hand side is square root of 4, which will give you two values
Oh,
again.
over
Plus
here, this
2 minus 2. You have two different values of h. But when you put h square is equal to 9, because we also had two values for v, so now I will put h squared is equal to 9, which means h is equal to,
root 9.
of course, root 9, which is plus minus 3, right?
Yes, sir.
Again, two values, plus 3 and minus 3. Look, what is h? H is the length of a triangle. H cannot be negative. It is supposed to be a length. Length is either 0 or some positive value, right? So our right values are going to be either 2 in positive or 3, though we have 4 values because it was biquadratic. The possible values of h are 2 or 3. So what will be b? Now you remember this part.
It
So possible
will
values for b are going to be 6 over h, which means 6 over 2, or b is going to be 6 over the next value is positive 3, which is
2.
2. That's your final answer, I guess. Yeah. Which means now you can pair up.
It's just swapped. So the
Yeah, yeah.
answers are either 3 and 2 or 2 and 3.
Yeah, so now you have to pair up. When h was 2, you had b as 3. And when h was 3, you have b as
Yes, 2.
2.